Show that the circles x square plus y square plus 2ax plus c equals to 0, x square plus y square plus 2by plus c equals to 0 touch each other if 1 by a square plus 1 by b square equals to 1 by c. So, since the two circles touch each other, but how the two circles are going to touch? What I mean to say is external touching or internally touch each other. So that we don't know. That is why the condition for the two circles to touch each other is C1 C2 equals to R1 plus or minus R2 we shall take. So let the equations of the circles be S x square plus y square plus 2ax plus c equals to 0, s dash x square plus y square plus 2by plus c equals to 0. So the center for the first circle is c is equals to minus a comma 0. Radius r1 is equals to square root of g square plus x square minus c. So a square minus c. C2 second circle center is 0 comma minus b. Radius r2 equals to square root of b square minus c. Since the two circles touch each other implies, and what is C1 C2? C1 C2 is square root of 0 minus a whole square, so a square minus b minus 0 whole square, so which is b square. Touch each other. C1 C2 is equals to R1 plus or minus R2. C1 C2 is square root of a square plus b square is equals to R1 is equals to square root of a square minus c plus or minus square root of b square minus c. So let us square on both sides. Squaring on both sides. Then square root gets cancelled. A square plus b square equals to a plus or minus b whole square. A square plus b square plus or minus 2 root of a into b. So this is a square minus c. This is plus b square minus c. A square plus b square plus or minus 2ab. 2 root of a square minus c into b square minus c under root. Single root. Otherwise I will write here plus or minus 2 root of a square minus c into b square minus c. This is equals to a square, b square, a square, b square gets cancelled. So this is 2c is equals to plus or minus 2 root of a square minus c into b square minus c. So 2 gets cancelled. Again square on both sides. Again squaring on both sides. So we will be getting c square is equals to a square b square minus a square c minus b square c plus c square. C square gets cancelled. So this is minus of a square c into b square c. If you bring to this side, then c into a square plus b square is equals to a square b square. This implies c is equals to a square b square by a square plus b square. So if it is c, then what is 1 by c? 1 by c is equals to a square plus b square by a square b square. Therefore a plus b by c, a by c plus b by c, a square by a square b square, a square gets cancelled, 1 by b square, b square by a square b square, b square gets cancelled, 1 by a square. Therefore 1 by c is equals to 1 by a square plus 1 by b square, which is to be proved. Show that the circles touch each other. Find the coordinates of the point of contact. Is the point of contact external or internal? So let us see C1, C2, R1 plus R2 it holds, or R1 minus R2. So let the circles be S, x square plus y square minus 2ax equals to 0. So center C1 is equals to a comma 0 and radius 2x is this, this is 2x equals to 0. Therefore center is 1 comma 0 and the radius r equals to square root of 1 square. So r equals to 1, r1. And the second circle is s dash x square plus y square plus 6x minus 6y plus 2 equals to 0. C2 is equals to center of this circle is minus 3 comma 3 and radius r2 is equals to square root of 3 square 9, 3 square 9, 9 plus 9 18 minus 2 16, root 16 is 4. Now C1 C2 is, this is x1 y1 and this is x2 y2, square root of x2 minus x1 whole square plus y2 minus y1 whole square, that is equals to minus 3 minus 1 is minus 4 whole square 16 plus 3 minus 0 whole square 3 square 9 root 25 which is 5. So clearly we can see C1 C2 is equals to R1 plus R2. Therefore the two circles touch each other. Touch each other is okay. How these two circles touch each other? Externally. So immediately the relative position of the two circles must write to our mind. So this is C1 and this is C2. So the relative position of these two circles will be C1 C2 is this. This is S equals to 0. This is S dash equals to 0. Now so find the coordinates of the point of contact. Is the point of contact internal or external? First of all, this is the point of contact P. Clearly this diagram shows that P is the internal point. So therefore the point of contact is an internal point. To be more specific, P is the internal center of similitude. Internal center of similitude. So therefore, what is P? What is the formula for P? R1 x2 plus R2 x1 by R1 plus R2, R1 y2 plus R2 y1 by R1 plus R2. This is equals to R1 x2. This is x1 y1, x2 y2, R1, R2, everything we have. R1 x2 1 into minus 3 plus R2 x1 4 into 1 4 by R1 plus R2 4 plus 1 comma R1 y2 1 into 3 plus R2 y1 4 into 0 by R1 plus R2. So therefore the answer we get is minus this is 1 by 5 comma 3 by 5. Find the equation of the circle which cuts the following circles orthogonally. 3 circle equations are given. So for your information, the same kind of problems that we have already discussed in exercise 2a, 3rd Roman, 5th problem. So there the radical axis, radical center concept is not discussed. Then therefore actually the 3 circles are like this. One circle cuts all these 3 circles orthogonally like this earlier. Therefore, x square plus y square plus 2gx plus 2fy plus c equals to 0, the general equation of the required circle we have taken. This is s dash equals to 0, s double dash equals to 0, s triple dash equals to 0. We have taken before. And 2gg dash plus 2ff dash is equals to c plus c dash. So that condition we had used thrice for this and this and this and this and this and this 3 equations. Therefore actually these 3 simultaneous equations we saw solved. Then actually G, F, C values we got before. Now the concept of radical axis is introduced. Therefore we no need to use that 2gg dash plus 2ff dash is equals to c plus c dash condition thrice. But instead actually this is the required circle which cuts these 3 circles is to be found out. Therefore the radical axis of these 2 circles, let us suppose that this, and the radical axis of these 2 circles is this, and the radical axis of these 2 circles is this. But actually third is not required, of course, otherwise okay. So but to obtain the center, to obtain the point, minimum 2 lines are needed. Therefore this is not required. Now this center is said to be the radical center. What is radical center? The point of intersection of radical axis is nothing but radical center, and that center is the center of that radical center is the center of this required circle. So therefore actually center we will get. But how do we find the radius? Radius is nothing but the length of the tangent drawn from the center of this circle, that is radical center, to any of the 3 circles. Let us suppose that I have taken this. So this circle, so this is root S11. This root S11 is nothing but the radius of the required circle. So in this fashion we will solve this problem. So, and one more thing, the same kind of problem we have discussed before in 4th problem, 2nd Roman 4th problem, 2nd question. 2nd Roman 4th problem, 2nd question. There the radical center is C is equals to 2 comma 1 we have got. So you may check it out also. Now this C is equals to 2 comma 1 is these 3 circles are given, and therefore this is the circle that is to be found out. Okay, for this that C is 2 comma 1, C is 2 comma 1, and the C is equals to 2 comma 1 is the center of the required circle which is orthogonal to the given 3 circles. Now to obtain radius, let us find the length of the tangent from C 2, 1 to any of the 3 circles. So let us consider the third circle. But again I am telling you, not only the third circle, you may take the second as well as first circle also. All of them got the similar answer, which is root S11. So now root S11 is root of x1 square plus y1 square plus y. So this x1 y1 is 2, 1. So 2 square plus 1 square plus 1 square. This is equals to root 6. That means this length of the tangent is from this to this circle. This is 6, root 6. Therefore, we have the center C, h, k and the radius r. So, x minus h whole square plus y minus k whole square equals to r square. Therefore, the equation of the required circle having center C is equals to 2, 1 and radius r equals to root 6 is x minus h whole square plus y minus k, this is h comma k, y minus 1 whole square is equals to r square root 6 whole square. Square root gets cancelled. So this is x square plus y square minus 4x minus 2y. This is 2 to the 4, 1. 5 minus 6, which is equals to minus 1 equals to 0. Now the third question from the same bit. Find the equation of the circle which cuts all the 3 circles orthogonally is the question given. So I have taken S, S dash, S double dash. So there are 3 circles given. This is S is equals to 0. This is S dash equals to 0. This is S triple dash double dash equals to 0. Cutting these 3 circles orthogonally, one big circle is going. So then actually the radical axis of any 2 circles we will find. So L is S minus S dash equals to 0. 2x minus 7x minus 5x. 17 minus 6 is 11y. 4 minus 11 is minus 7 equals to 0. 2x minus 7x minus 5x. 17 minus 6, 11. 4 minus 11 minus 7. So therefore this is 5x minus 11y plus 7 equals to 0. This is L1. L2. S minus whatever. S minus S double dash equals to 0. So 2x minus of minus 3x. 17 minus 22 minus 5y. 4 minus 3 is plus 1 equals to 0. That means for these 2 circles S and S dash, this is the radical axis. And for S and S double dash, this is the radical axis. So actually these two lines, if I solve, then actually this point of intersection we are going to get, and this point of intersection is said to be the radical center, which is which we got through solving the radical axis of any two circles. So now solving 1 and 2. So 5x minus 11y plus 7 equals to 0. 3x minus 5y plus 1 equals to 0. X by y by 1 by cross multiplication method. X minus 11 ones are minus 11 minus 5 sevens are 35 minus of minus plus 35. Next y by 3 sevens are 21 minus 5 ones are 5. 1 by minus 25 plus 33 is 8. Therefore x comma y is 24 by 8 3, 16 by 8 is 2. Therefore this is the radical center of the required circle, that is cutting all the three circles. Okay, so for this circle, this is 3 comma 2 we get. Now therefore 3 comma 2 is the radical center of the three circles, radical center of the required circle which cuts the given circles, orthogonally. Now to find the radius, so radius of the required circle is the length of the tangent drawn from radical center C 3 comma 2 to any of the three circles. So let us consider second. So root S11 is root for the second circle I am taking, or the third circle also. So x1 square plus y1 square, and this is my x1 y1. So the third circle is there, so this is the length of the tangent, so this is root S11. x1 square plus y1 square plus 7x1 plus 6y1 plus 11, this is equals to 3 square 9, 2 square 4, 7 3s are 21, 6 2s are 12 plus 11, 9 plus 4 13, 13 plus 12 25, 25 plus 21 plus 11 6, this is 5 1 7, 2 plus 2 4 5, so root 57. Therefore this is root 57. We have the center C h comma k and radius is equal to root 57. Therefore equation of the required circle having center C is equals to 3 comma 2 and radius r equals to root 57 is x minus 3 whole square plus y minus 2 whole square is equals to root 57 whole square. Square root gets cancelled. This is x square plus y square minus 2 3s are 6x minus 2 2s are 4y. This is 3 3s are 9, 2 2s are 4, 13, 9 plus 4 13, 13 minus 57 4 minus 44 equals to 0. For the sake of your convenience, let us try to solve this problem in both the ways. So since the required circle cuts the three circles orthogonally, let us take the required circle B, x square plus y square plus 2gx plus 2f plus c equals to 0. Let us take this to be s dash, s double dash, s triple dash, and the orthogonal condition 2gg dash plus 2ff dash equals to c plus c dash. Let us use it for both of the three and solve. Then GFC values we will be getting. That is one method. Otherwise, the second method is what we are discussing. Okay, so let us try to do the problem in both the ways. So let the equation of the required circle be s, x square plus y square plus 2gx plus 2fy plus c equals to 0. Let the given circles be, let the given circles be s, s dash, s dash, s double dash, s triple dash. This is the last problem, fourth bit. Since the required circle cuts, required circle s is equals to 0 cuts s dash equals to 0, s double dash equals to 0 and s triple dash equals to 0 orthogonally. That implies 2g dash is to 2f dash 1 plus is equals to c plus 1. This is 4g plus 2f minus c minus 1 equals to 0. So let this be 1 and this be 2. Next, first let us, this is not the general equation for which we need to divide this by 2. Then s double dash is x square plus y square plus 4x plus 3y minus 3 by 2 equals to 0. So now for this s is equals to 0 cuts s double dash equals to 0 orthogonally implies 2g dash for 2f dash 4 by 2 that is 2. So 2f dash 3 by 2 is equals to c plus c dash 3 minus 3 by 2. 2 gets cancelled. 4g plus 3f minus c plus 3 by 2 equals to 0. Third equation. Now since the required circle s equals to 0 cuts s triple dash equals to 0 orthogonally implies 2g dash is g dash is 3 here plus 2f dash 2f dash is minus 1 is equals to c minus 3. This is equals to 6g minus 2f minus c plus 3 equals to 0. Fourth equation. Now let us subtract 3 and 2. So 3 minus 2 gives rise to 4g minus 4g gets cancelled. 3f minus 2f is f. 3f minus 2f is f. This is minus c plus c gets cancelled. This is 3 by 2 plus 1. 3 by 2 plus 1. 2 ones are 2 plus 3 5. So 5 by 2 equals to 0. This is f equals to minus 5 by 2. Okay, next let us try to subtract 4 minus 3. 4 minus 3. 6g minus 4g is 2g. Minus 2f minus 3f minus 5f minus 2f minus 3f minus 5f minus c plus c gets cancelled. This is 3 minus 3 by 2. 2 3s are 6 minus 3, 3 by 2. This is plus 3 by 2 is equals to 0. Now substituting f we get, so 2g minus 5 into f is minus 5 by 2 plus 3 by 2 equals to 0. That implies 2g minus into minus plus 5 is a 25 by 2 plus 3 by 2 equals to 0. 2g plus 25 plus 3 is 28 by 2, which is 14 equals to 0. Therefore g is equals to minus 7. Substituting g comma f in any one of the equations, like fourth equation or second equation, implies 4 into g value is minus 7. 2 into the value of f is minus 5 by 2 minus c minus 1 equals to 0. 2 gets cancelled. Minus 28 minus 5 minus c minus 1 equals to 0. Minus 28 minus 5 minus 33 minus 34. So minus 34 minus c. Minus 34 minus c equals to 0. C is equals to minus 34. Therefore C is equals to minus 34. Substituting G, F, C in first equation. So x square plus y square plus 2gx. 2x into g value is minus 7. 2fy. 2y into the value of f is minus 5 by 2. Minus 5 by 2. C value is minus 34 equals to 0. 2 gets cancelled. Therefore x square plus y square minus 14x minus 5y minus 34 equals to 0. This is one method, and let us try to solve this method in the present method that we are discussing through the radical axis, radical center type. So go on, Raitu. Let us do the problem in the present method, that is radical axis, radical center type. So s dash, s double dash, s triple dash I have taken now. So 2s dash, s double dash, this is s double dash minus s dash. 2s dash, let us do s double dash minus s dash equals to 0. So this be L1. L1 is the radical axis of these two circles. Therefore, to this we may divide by 2, or this we will multiply with the 2. So this is better, because if I do, the fractional values we will be getting. Of course, actually fractional values also if we get, no problem, but the simplification would be a little bit difficult. So s double dash minus s dash. So 2x square, 2x square, 2x square cancel. So 8x minus 8x, 0. This is 8x, 2 4s are 8x, 8x gets cancelled. 6y minus 4y, 2y. This is 6y minus 2 into 2, 4y, so 2y. Next, this is minus 3 minus 2 equals to 0. This is minus 5 equals to 0. Then we get 2y minus 5 equals to 0 as one equation, and L2 is equals to s dash minus s triple dash equals to 0. I will take x square, y square gets cancelled. Otherwise s triple dash minus s dash I'll do. So 6x minus 4x is 2x. Minus 2y minus 2y minus 4y minus 3 minus 1 minus 4 equals to 0. Therefore this is x minus 2y minus 2 equals to 0. So from this y is equals to 5 by 2 I get. Y equals to 5 by 2. Substituting y in x minus 2y minus 2 equals to 0 implies x minus 2 into y value is 5 by 2 minus 2 equals to 0. So 2 gets cancelled. X minus 5 minus 2 is minus 7. Therefore x equals to 7. Therefore 7 comma 5 by 2 is the center of the required circle. Center of the required circle. Now so to obtain the radius is radius of the required circle is equals to length of the tangent drawn from center C 7 comma 5 by 2 to any circle. So to first circle I will take to s equals to 0. Then root s11 dash is equals to square root of x square x1 square plus y1 square, this being x1 y1 plus 2g x1, so that is 4x1 plus 2y1 plus 1. This is equals to 7 square 49, 25 by 4, 4 7s are 28 plus 2 into 5 by 2, 2 gets cancelled, 5 plus 1. 49 plus 1, 50, 55, 55 plus 28, 83. So this is equals to 83 plus 25 by 4. So 4 3s are 12, 1, 4 8s are 32 plus 1, 33 plus 25, 7, 5, 357 by 4. This is equals to root 357 by 4. Therefore, equation of the required circle having C is equals to 7 comma 5 by 2 and radius R equals to root 357 by root 4, which is 2, is x minus 7 whole square plus y minus 5 by 2 whole square is equals to 357 by root 2 whole square is 4. This is x square, 7 square 49, 2 7s are 14x plus y square, 5 square 25 by 4 minus 2 into 5 by 2, 2 into 5 by 2 into y, 2 gets cancelled. So 5y is equals to 357 by 4. So this is equals to x square plus y square minus 14x minus 5y. Next 40, this is equals to 357 by 4 minus 25 by 4. This plus 49 is minus 49 if you transpose. So 357 by 25, 357 minus 25, 2, 5 minus 2 is 3. So 332 by 4. 4 8s are 32, 4 3s are 12. So this is 83 minus 49. This is equals to 13 minus 9 is equals to 4. This is 7 7 minus 4 is 34. Therefore, x square plus y square minus 14x minus 5y minus 34 equals to 0. I did not rub the answer that I got in the first method, that is x square plus y square minus 14x minus 5y minus 34 equals to 0. You can compare. So with this, we wind up the system of circles chapter.